Trigonometry is not just theory, it solves real-world problems. From standing on the ground to reaching for the sky. Trigonometry turns angles into answers, measurements into solutions, and mathematics into real-world understanding.
Good evening, Namaste. Welcome to Infinity Math Studio. Nenu Pranay sir. In today's live, we are going to explore regarding applications of trigonometry in solving real life problems. As you can see on the screen, there are some persons who are trying to calculate and do something with the heights and distance. So these are the real applications of trigonometry. Today that we are going to explore it. Once again, welcome to Infinity Math Studio. So, in today's live session, I'm going to explain the step-by-step solutions of exercise 12.1 mathematics of class 10. There are 9 problems and 10 problems in exercise 12.1. In this live session today, we will solve all 10 problems with detailed, neat explanation. In a minute, we'll start. Welcome to newly joined audience. Please stay on the live. Those who are in the live, please stay tuned. Don't leave the live session in the middle. Once started, you will enjoy this live session today. And I really thank to join the live session today at 4 p.m. We'll start the live session solving 12 problems in a couple of minutes. Please stay tuned. You can utilize the live chat also for conveying your feedback. Welcome to Infinity Math Studio once again. Who joined right now? Stay tuned. Don't leave the live session. In a couple of minutes, I'll start solving exercise 12.1 neatly.
Trigonometry turns angles into answers, measurements into solutions, and mathematics into real-world understanding.
I request all of you to utilize the live chat where you can express your feedback and doubts. All right, the wait is over. Here in today's live session, now exercise 12.1 of class 10 mathematics, Telangana and Andhra Pradesh board, both students can refer this live session. Right, we'll jump into the exercise 12.1 today. The first question is, on the screen, a tower stands vertically on the ground from a point which is 15 meter away from the foot of the tower. The angle of elevation of the top of the tower is 45 degree. What is the height of the tower? So here I would like to give you a basic detail of few terminology. As you can see on the screen, angle of elevation. So in these applications of trigonometry, we must learn four very important phrases. First one is line of sight. This is the most important. I will explain each and everything. Second one, horizontal or horizontal line. The third one is angle of elevation. And the fourth one is angle of depression. So these are the four very important phrases that everyone must remember. Now I will explain all these four terms. Please utilize the live chat. So first one, line of sight. Before going to this line of sight, we'll see first one, observer, and the second one, target or destination. Okay, observer is nothing but the person who observes. Observes or investigates is called a observer. The second one, target, is nothing but destination. What the observer is investigating, that is called target. So based upon this observer and target, this line of sight and all will come into picture. So as you know what are observer and target, now let us go to the line of sight. For example, this is the ground level. This line is the ground level. You are standing here. There is a tree here. You are observing the top of the tree. So this is the top of the tree. You are observing by raising your head. By raising your head, you are observing the target which is above the ground level. Since you are observing the target by raising your head, this line in which direction you are observing the target is called as line of sight. Okay. So here, since we are observing, we are called as observer. And since we are observing the top of the tree, this top of the tree is called as target. Okay. And this horizontal line which you can see is the reference of ground level. So this ground level reference line is said to be simply a horizontal line. Horizontal line. Okay, all right. So now line of sight is nothing but the line which observer observes the target is called line of sight, and horizontal is the line which is drawn horizontally with reference to the ground level. Now in this case, the observer is raising his head and observing the target above the ground level. So the angle formed between the line of sight and the horizontal is called angle of elevation. Since the observer's head is raised and the target is above the ground level, this type of angle formed between the line of sight and the horizontal is said to be angle of elevation. Now, angle of depression is also the same angle formed between the line of sight and the horizontal, but in this case of depression, the observer will lay down his head. He faces his head towards the target which is below the eyesight of the observer. This can be explained using a neat diagram. First of all, we'll solve this first question. Now, if you observe the image which you can see, so you can look at the image and now read the question. A tower stands vertically on the ground. In the image, you can see the tower which is standing vertically on the ground from a point A. As you can see, from a point A, observer is observing the top of the tower. Okay. Now, this dotted line which is you can see on the screen is called as line of sight. Okay. And the ground level which you can see at the bottom, this is called as horizontal line. Now since the observer is raising his head to observe the top of the tower, hence the angle formed between the line of sight and the horizontal is called angle of elevation. I hope you understood now very clearly. The observer is raising his head to observe the target. Hence, the angle formed between the line of sight and the horizontal is said to be angle of elevation. All right. Now, if you observe it very clearly, there is a right angle formed in this diagram. Now you see this red color line BC is standing perpendicular to the ground level. AB. And if I join the points A and C, it becomes the hypotenuse. So here, in order to find the height of the tower using the distance between the foot of the tower and the observer and angle of elevation, we use trigonometric ratios. Now, I have drawn one right angle triangle. Let it be A, B, and C. Here AB is the tower which is standing perpendicular to the ground level, and here the angle is given as 45 degrees, which is the acute angle that we have to consider it as theta value. Height of the tower we don't know, so I assume it as h, and the distance he gave is 15 meters. Now here we need to find the height. Okay, now the solution is like this. In triangle ABC, AB is the tower which you can see on the screen, and BC is the distance between the observer and the tower. It is given as 15 meters. Now angle of elevation, the name of the angle is C. Angle C is equals to 45 degrees, which we assume it as acute angle theta. Now with respect to this acute angle theta, we can say that AB is the opposite side, right? That I write here, with respect to theta, AB becomes the opposite side. Next, BC is equals to 15 meters will be the adjacent side. This you will learn in a trigonometry chapter. What is acute angle, what are opposite side and adjacent side to acute angle, that you supposed to learn in trigonometry. So now, since we have opposite and adjacent, we take tangent of that particular tangent ratio we will consider. So tan theta formula is opposite side divided by adjacent side. So theta value he gave 45 degrees. Opposite side we have h, by adjacent side we have 15. And from the trigonometric ratio table, we have tan 45 value as 1 is equals to h by 15. Now 15 transposed to this side, it becomes 1 multiplied by 15, and that is equals to h. So here, if I interchange the LHS and RHS, I can write it as h is equals to 15. So therefore, the height of the tower is exactly 15 meters. So this is how, without the help of measuring tapes and all, we can find the height of the tower. This is all about first question. It is that simple. Now without doing any further delay, we'll go for the next second question. On the screen, a tree breaks down due to storm and the broken part bends so that the top of the tree touches the ground by making 30-degree angle with the ground. The distance between the foot of the tree and the top of the tree on the ground is 6 meters. Then we have to find the height of the tree before falling. It's very interesting even. If you see the question, it is too long, but if you see this diagram, your doubts will be cleared off. Now, in the diagram, you can see there is a tree broken due to wind or storm, right? You can see it very clearly. and the top of the tree is touching the ground and making an angle of 30 degrees with the ground level. All right. Now you see in the photo, you have 6 meters red color line it is representing. That is the distance between the foot of the tree and top of the tree. Now here, this is the foot of the tree and this one is the top of the tree. Now here, the distance here between foot of the tree and top of the tree is given as 6 meters. So we need to find the height of the tree before falling down. That means here we need to find this height and the length of this broken part also. Individually, we need to find these two sides and then we need to add them to get the total height of the tree before falling down due to storm. Now, if you see it very clearly, this is forming a right angled triangle, right? So, representative of this one will take an imaginary right angled triangle as shown on the screen. Now here you can see this dotted line is nothing but it is the tree which is there before falling down. Now this part is broken and it is lying on the ground like this. So you need to understand this one. Oh. Now let me name these things. Let it be point D, point B, here it is C and A. The tree is standing perpendicular to the ground level. Now top of the tree is touching the ground and making 30 degrees angle. And the distance given as 6 meters. Okay. Let's solve this one. Let from the figure AB be the height of the tree before falling down. Okay, this is most important, before falling. So AB is the height of the tree before falling down. Okay, right. Next, let the tree broke at point C. Okay, consider that at point C the tree broke and touches the ground at point D. Touches the ground at point D. So as you see clearly in the screen. Now from the figure, top of the tree is not A now. Top of the tree is nothing but point D. Okay. And foot of the tree, if you see from the diagram, foot of the tree will be as it is point B. Okay. And the distance between the top of the tree and foot of the tree is given as BD is equals to 6 meters. And from the figure, angle BDC is given as 30 degrees. Okay, we received one live chat, similar triangles. Okay, I'll definitely make a video upon similar triangles also. If you are interested, thank you so much. Now, let's continue. Angle BDC is 30 degrees. Now, in triangle BDC, if you observe BDC triangle, in that triangle, angle B is equals to 90 degrees. So, angle BDC. Okay. Now, that became a right angle triangle. In that, acute angle is with respect to acute angle theta is equals to 30 degrees. Here is your acute angle. With respect to this, BC becomes the opposite sides. You must not consider this dotted line because it broke and fell down. So you must consider only triangle BDC. In that BDC, your acute angle is 30 degrees with respect to this, BC will be the opposite side and BD will be the adjacent side. Okay, right. So with respect to theta, BC is nothing but opposite side. Next, BD, it is adjacent side, and CD is the hypotenuse. So we named all three sides of a right angle triangle. Now let us apply the trigonometric ratios. Here you remember these things. We need to find the length of BC, this length as well as this length. If we find lengths of hypotenuse and this opposite side, then if we add both of them, we get the height of the tree before falling. This is the most important point to remember. So now apply tan ratio. So tan theta is equals to opposite side by adjacent side. Now substituting the values, tan theta is equals to opposite side is BC by adjacent side is BD, and tan theta value we have tan 30 degrees. Tan 30 degrees from the table, it is 1 by root 3 is equal to BC value we don't know actually, so put it as it is BC. BD value is 6. All right, now put BC here only, transpose this divided by to this side, it becomes multiplication to 1 in the numerator. So BC is equal to 6 by root 3. Here denominator is irrational number, so we have to rationalize that denominator. So what I do, I multiply with root 3 and divide by root 3 as it is. Now 6 into root 3, we write 6 into root 3 only. Now here 3 root 3 into root 3, it becomes 3. Now 3 ones are 3 twos are. So answer is 2 root 3. Now you have found one part of the broken tree, it is 2 root 3. All right. Now second part. For this, we need to consider ratio sin 30, because here we have to find the hypotenuse. You can use cos 30 also, no issues, no problem. Depending upon the requirement and given sides, you can choose sin, cos, tan, depending upon your given conditions. Here I am taking a sin 30, which is opposite side BC. Let me write the formula. Opposite side by hypotenuse. So sin 30 value is 1 by 2. Opposite side became 2 root 3. And hypotenuse is nothing but CD. Here hypotenuse we don't know, we transpose this to this side and at the same time this side. So 1 into CD becomes CD and 2 into 2 root 2. So here 2 into 2 root 2, we write it as 4 root 3. So CD value we have 4 root 3. BC value we have 2 root 3. And I already told you the AB is the height of the tree before falling. So from figure, what we write? AB is equals to BC plus AC. Here CA value. Here if you observe, one thing you must remember, please don't get confused. From the figure, you can see that AB is the actual height of the tree. So this tree broke at point C. Now this part is fallen down and touching the ground at point C. That means this CD line and CA line both are same. whatever the length we have found, it is 4 root 3. So AC value also becomes 4 root 3 only. But while writing, we must not write CA here. So from figure you can see it as BC plus AC. Okay, but we did not find AC value directly, and still it is equal to CD only. So what we write here is, from figure, AB is nothing but total height of the tree. Okay, total height. That means BC plus CD gives the value of AB. Okay, don't get confused here. So BC value is 2 root 3 and CD value is 4 root 3. So if you add them, you get 6 root 3. If you stop here, you'll get the full marks. If you want to simplify even more, you can multiply the root 3 value to 1.732. If you multiply 6 with 1.732, you will get some answer. So this one is also right, but you can stop the answer here only. So the height of the tree before falling down due to storm is 6 root 3 meters. Next, third question. A contractor wants to set up a slide for the children to play in the park. He wants to set it up at a height of 2 meters and by making an angle of 30 degrees with the ground. What should be the length of the slide? So very interesting. You can see the slide setup on the screen. So the contractor wanted to set up the slide at 2 meters height as shown on the screen. And that blue color slide is making 30 degrees angle with the ground. So in order to arrange the slide in the concerned setup, what must be the length of the slide? That is the question. Okay, now hope you understood this question using this diagram. So slide must be set up 2 meters high. Okay, right. Now using this setup, we will draw a right angled triangle. So this is the right angled triangle. In this right angled triangle, I am naming it as B, which is 90 degrees to the ground level, and it is AC. Now from the figure, AC will be the slide. This is the slide. We need to find the length of AC. Whereas this BC height is given as 2 meters and the slide is making 30-degree angle with the ground level. Okay. Now here with respect to this acute angle, given height is opposite side and the to find the side is hypotenuse. So opposite side versus hypotenuse. What is that side trigonometric ratio where we use opposite side to hypotenuse? Is nothing but cos theta. Here you can use cosecant theta also. Simply cosecant theta is the reciprocal for sin theta. So generally we take basic trigonometric ratios, sin, cos and tan only. We don't require use reciprocal ratios. Okay. So here I am writing the given diagram. So BC be the height considered. Okay. This is the height considered by the contractor. Okay. And from the figure, AC be the length of the slide that we have to calculate. Length of the side. Now angle of elevation is given as 30 degrees. Now in the triangle ABC. From the figure, in triangle ABC, angle B is equals to 90 degrees. So it became a right angle triangle, where with respect to our acute angle theta, BC is equals to 2 meters given, and it is the opposite side to acute angle. Opposite side. And next, AC is equals to, we need to find this one, and this is the hypotenuse. So what is the trigonometric ratio between opposite to hypotenuse? Is nothing but sine theta only. So sine theta formula will be opposite side by hypotenuse. Okay, right, we'll solve here. So sine theta, theta value given as sine 30 degrees is equals to opposite side is BC by hypotenuse is AC. Sine 30 from the table we have it as 1 by 2, and BC value he gave 2 meters, and AC we don't know. Just to transpose the terms, you get AC. AC you transpose this side. So 2 goes this side. So 2 into 2. So AC value you have 4. AC is nothing but length of this slide. That means what should be the length of this slide? Length of slide must be how many meters? 4 meters. So if we wanted to set up this slide at a height of 2 meters, so the length of this slide must be exactly 4 meters. Then only the slide will be correctly arranged. This is the calculation. I hope you have understood. If you are understanding, please like the live session. Next, fourth question. Length of the shadow of a 15-meter high pole is 15 root 3 meters at 7 o'clock in the morning. Then what is the angle of elevation of the sun rays with the ground at that time? So you can see the tower or a pole which is standing perpendicular to the ground level at 7 o'clock in the morning. So sun is the rising. So now you can see the sun rays. Here you can see the sun rays falling like this. So if the sun rays is falling like this, so shadow will be formed. You can see on the screen. So this one is forming a right angle triangle if you observe. Okay. Now the length of the shadow is given as 15 root 3. This length of shadow is 15 root 3. And the height of the pole is given as 15 meters. If the height of the pole is 15 meters and the shadow formed is 15 root 3, we need to find the angle of elevation of the sun. That means this angle we need to find, theta we need to find. Okay, I hope you have understood the diagram and the question. Here the angle of elevation of the sun rays we need to find, so that height of the pole is 15 meters and length of the shadow is 15 root 3 meters. Right, now we'll take an imaginary right angle triangle where PQ is representing the pole standing perpendicular to the ground level, and the QR is the length of the shadow. It is given as 15 root 3 meters, and height of the pole is given as 15 meters. Here we need to find the theta value. So with respect to theta, given height becomes opposite side and given length of the shadow becomes adjacent side. Here we no need to find the hypotenuse. Okay, so let us write the given information. Let PQ be the height of the pole. PQ be the height of the pole, and QR be its shadow. And theta, that is angle R, is the angle of sun rays you consider. Angle of sun rays with the ground. Okay. Now which triangle is formed? in triangle PQR, we know that angle Q is equals to 90 degrees, hence it became a right angle triangle. So with respect to our finding acute angle, what is this PQ? PQ is equals to 15 meters and it became the opposite side. And what is this length of shadow QR? That is 15 root 3 meters and it became the adjacent side. Okay. Now opposite versus adjacent, what trigonometric ratio we have? It is nothing but tan ratio. So tan theta is equals to opposite side by adjacent side. So substituting the values, we don't know theta, so write as it is. Now opposite side is PQ, adjacent side is QR. Substitute the values again. Tan theta is equals to PQ is 15, QR is 15 root 3. This one I am writing it as 15 ones are 15 and this one I write it as 15 into root 3. Now 15 gets cancelled. What is left? 1 by root 3 is left. So finally we have tan theta is equals to 1 by root 3. So for what value of theta, tan ratio becomes equal to 1 by root 3? If you check the trigonometric table, it will be exactly 60 degrees. Why? Because you see sine 60. Let us check whether we are right or not. So if you don't remember the values of tan, still there is no problem. I'll tell you a trick. If you can remember sine 60 value as root 3 by 2 and cos 60 value as the opposite, right? 1 by 2. Okay. So this much if you can remember, you can tell this confidently 60 is right or wrong. This is simply a small check when you don't remember the tan ratios. So tan ratio is nothing but sine by cos. So tan theta can be written as sine theta by cos theta. Sine theta you remember, cos theta you remember. So same root 3 by 2 by root 1 by 2. So by 2 gets cancelled. So you will be left with root 3 by 1. But here we have 1 by root 3. So our assumption 60 degrees is wrong. So what will be other choice? Definitely it must be sine 30 by cos 30. Right? So if you don't remember all those things, there is only one option, that is to remember the trigonometric ratio table compulsory. Okay. I will tell you a trick to remember the trigonometric table in the upcoming videos. So tan theta will be is equals to 1 by root 3 at theta is equals to 30 degrees. Okay. At theta is equals to 30 degrees in the 7 o'clock, 15 meters height pole will cast a shadow of 15 root. So this is all about fourth question. Next, fifth question. On the screen, you want to erect a pole of height 10 meters with the support of 3 ropes. Each rope has to make an angle of 30 degrees with the pole. What should be the length of the rope? Here, you see the diagram, then you will understand. That blue color pole is 1. Its height is 10 meters. To erect that pole perpendicular to the ground, we have taken the help of 3 ropes, as you can see on the screen. So there are 3 ropes that are tied to the top of the pole and pulled and tied to the ground level, so that each rope is making 30 degrees angle with the pole but not with the ground. That you must remember. So rope is making 30 degrees angle with the pole but not with the ground. And here one more thing we need to assume, that the lengths of 3 ropes are same. So we need to assume that the length of 3 ropes must be the same. So that's why we find the length of one rope so that you can have the remaining two ropes also the same length. Here, three right angle triangles will be formed, each with one rope. So here for reference, we will take only one right angled triangle. Now that is the one right angled triangle, only one rope. Here the hypotenuse becomes the rope. Okay, so this is the reference triangle with one rope ABC. Here it is 90 degrees. AB is the pole 10 meters. And here, if you write theta, you will go wrong because rope is not making theta with horizontal. It is making with the pole. This is theta. Okay. So that we need to find the length of the rope. Hypotenuse here we need to find. With respect to theta, given 10 meters height of the pole is adjacent side. So here we need to find the ratio which is between adjacent side and hypotenuse. So let us write. Let AB be the height of the pole. Next, AC is the length of rope. Length of rope. Here we need to take this condition. Assume three ropes has same length. That is what the important assumption. Okay. Three ropes has same length. So in the triangle ABC, which angle is 90 degrees? Angle B is 90 degrees. It became a right angle triangle. Now, with respect to our theta, acute angle 30 degrees, what is given? AB is equals to 10 meters, which becomes the adjacent side. And what is to be found? AC we have to found. That is nothing but hypotenuse. So what is the trigonometric ratio? Is nothing but cos theta. Cos theta formula is adjacent side by hypotenuse. Substituting the values, cos 30 degrees is equals to adjacent side AB by hypotenuse is AC. Cos 30 value, if you can remember, it is nothing but root 3 by 2. AC we don't know, we write AC as it is. AB value it is 2. Now simple transpositions, root 3 into AC is equals to 2 into 10. Okay. Now root 3 transpose to this side, 20 by root 3. Here you can stop it here. Otherwise, if you divide 20 by 1.732, you will get approximately around 11.5 or something, 11.54 centimeters. So you can stop it here only. If you wanted to simplify it more, you can write 11.54 also. So this is how we find the length of the rope. Here one rope length is 11.54. So remaining two lengths also 11.54. He did not ask the total length of the rope. He told us to find the length of the rope simply. So that's why we found one rope length, that is 11.54 or 20 by root 3. So that's all for the fifth question. Next, sixth question is, suppose you are shooting an arrow from the top of a building at a height of 6 meters to a target on the ground at an angle of depression of 60 degrees. What is the distance between you and the object? Up to fifth question, you have the concept of angle of elevation. In all five questions, the targets are above the ground level. Now here the target is on the ground and the observer is above the ground. You can see the diagram. So in the image, the observer is above the building and above the ground level. The target is on the ground. Now the target is below the observer. So hence the observer must see downwards. So his head's looking downwards, right? Now, if you take this one as theta, you will be mistaken. And this one 60 degrees, here you don't consider this 60 degrees actually. So this is the image generated by the most famous artificial intelligence. Okay, right. Now I will explain you what is actually angle of depression. So here the observer will face downwards, will lower his head and look downwards towards the target. Now there is no horizontal here. As you can see, the red color dotted line is the line of sight actually. This red color line is the line of sight. So angle of depression or angle of elevation, it is the angle calculated between line of sight only. Line of sight and horizontal. Here at the point of observation, there is no line, horizontal line. If you can see here, there is no horizontal line. So you cannot say that this 60 degrees will be the angle of depression. Instead, I'll tell you very clearly, we need to draw an imaginary horizontal through the eyes of the observer. So now this is the imaginary horizontal line which is passing through the eyes of the observer. And this imaginary horizontal is parallel to the ground level. That means you can see this is the diagram. This is the actual ground level and we need to draw an imaginary horizontal. Now the observer is looking at the target like this. Now the angle of depression is nothing but the line of sight and horizontal in between angle is angle of depression. I hope you have understood this clearly. Right. We'll take an imaginary diagram like this. Okay. So here I have drawn a triangle. As you can see, the name of the triangle is A, B and C. Okay. Now BC is nothing but the building which he gave in the question at a height of 6 meters he gave. So a target at the ground at an angle of depression is 60 degrees. Here we need to draw an imaginary horizontal like this. Some CD. CD is the imaginary horizontal. Okay. Now the line of sight and the horizontal, the angle is nothing but theta, which is he gave 60 degrees. Okay. Now here we don't have a right angle triangle. Instead we have ABC. Now transversal concept, if you apply, this line CD is parallel to AB and AC is the transversal. This theta and this angle A both becomes alternate interior angle. So this becomes also 60 degrees. Now you have theta is equal to 60 degrees and you can apply trigonometric properties. Okay, this is what the analysis. Okay, now let us write our analysis part detailedly. Point C, imaginary horizontal as some P, it is parallel to AB, here it is perpendicular, given it as theta, this is 6 meters. Now let us write the steps. Let BC be the height of the building. C be the point of observation. Okay, from point C, observation is happening. Point of observation, and point A be the target. Okay. Now, since target is on the ground, we have angle of depression. Angle of depression. So that is theta is equals to 60 degrees. Now we need to draw an imaginary horizontal, that is CP is nothing but imaginary horizontal. Very important. Okay. Now, since CP line is parallel to AB line, and which one is transversal here? AC is transversal. Angle ACP, as you can see on the screen, ACP, this particular angle is equals to angle CAB, this one. Both are is equals to 60 degrees because they are alternate interior angles. Okay, right. Now, in triangle ABC, angle B is 90 degrees, hence it became a right angle triangle. With transversal concept, we came to know that angle A is also 60 degrees. Now, from the given data, we have BC is equal to 6 meters. With respect to our theta, BC will be the opposite side and AC will be the hypotenuse. Okay. Here what we need to find actually, what is the distance between U and the object. U in the sense observer. Observer is standing here and the target is at point A. So the distance between the observer and the target is nothing but AC. So we need to find the length of hypotenuse. Okay. What ratio we have? Opposite side and hypotenuse is nothing but sine theta. Sine theta is equals to opposite side by hypotenuse. Sine 60 degrees is equals to opposite side BC and hypotenuse is AC. Sine 60 is root 3 by 2. BC is 6 and AC is nothing but AC. Now simple transpositions, you get AC is equals to 12 by root 3. Now let me solve this in this box actually. So 12 by root 3, rationalize the denominator, root 3 by root. Okay. Now 12 root 3, 12 into root 3 by root 3 into root 3, 3. 3 ones are 3 fours are. So answer is 4 root 3. So what is the hypotenuse value? AC is nothing but 4 root 3. The distance between the observer and the object is 4 root 3 meters. Okay. Right. Now we'll go for the 7th question. An electrician wants to repair an electric connection on a pole of height 9 meters. He needs to reach 1.8 meters below the top of the pole to do repair work. What should be the length of the ladder which he use? Here, this is the first that we need to find. Length of the ladder we need to find. Next, when he climbs it an angle of 60 degrees with the ground, what will be the distance between the foot of the ladder and foot of the pole? These are the two things that we need to find in this question. So we'll see the image. So this is the image, as you can see on the screen. This is a current pole. Here, this is a top of the pole. Point B is the foot of the pole. Now from the top of the pole at 1.8 meters below, here the repair work must happen. Since the top of the up to top of the pole, total height of the electric pole is 9 meters, but the work must be happen here somewhat below the pole. Now the ladder has to place up to the repair work, making an angle of 60 degrees with the ground. Now here in this case, 60 degrees is the angle of elevation because the electrician must look upwards and work. So raise his head, hence it is called angle of elevation. Here instructions are very clear. Point to repair is nothing but 1.8 meters below the top. From here it is 1.8 meters. Now total height is 9 meters. From top up to here it is 1.8 meters. Now what will be the balance height of this pole is nothing but 9 minus 1.8. It is nothing but 7.2 only. Now here the distance between the foot of the pole and foot of the ladder also we have to find. That is why I mentioned it as x. And we have to find the length of the ladder also. That means hypotenuse we need to find, and this one of the side also we need to find. Okay, I hope you understood the diagram very clearly. Using this diagram, we have to draw an imaginary right angle triangle with all the given details. So here is the imaginary right angle triangle. Now this is a little bit bigger problem because here we need to find the two parameters. One is length of the ladder and distance. Okay. So diagram is ready. It is point D, foot of the ladder, point B, foot of the pole, point C, repair area, and A, top of the tower. Okay. Now ladder is making 60 degrees angle with the ground. Pole is making 90 degrees with the ground level. This we need to find it as, let it be x, and length of the ladder as L, for example. Okay. Now this length is given as 1.8 meters. Now the total length is given as 9 meters. Okay. Now let us write very clearly. Let AB be the height of the pole. Next, at point C, repair has to be done. Repair has to be done. Now angle of elevation given how much? Theta is equal to 60 degrees given. From the diagram, what are our observations? Let us write. CD is nothing but length of the ladder, right? Length of the ladder. Next, from the same figure, BD will be the distance between foot of the ladder and pole, both foot of the ladder and foot of the pole. Now in a triangle BCD, angle B is equals to 90 degrees, became a right angle triangle. With respect to our acute angle theta is equal to 60 degrees, BC will be the opposite side, and that is given as how much? BC is nothing but, from the figure, total length is AB, from that repair is AC, so that we get 9 minus 1.8 is 7.2 meters. So this becomes the opposite side to acute angle. Now BD is equals to X, we assumed, that becomes the adjacent side, and as usual DC is nothing but hypotenuse, we assumed it as L. Here we need to find adjacent side and hypotenuse. So for that we need to take two ratios here. So first ratio, we take sine theta. Sine theta is equals to opposite side by hypotenuse. Sine theta in the sense sine 60 degrees is equals to opposite side is BC, hypotenuse is DC. Sine 60 value root 3 by 2. BC is given as 7.2 from the calculation. DC we don't know and we assumed it as L. Now transpositions, L is equals to 2 into 7.2 by root 3. Rationalizing the denominator, we get L is equals to 2 into 7.2 by root 3. We multiply root 3 and divide by root 3. Next, L is equals to 2 into 7.2 into root 3 by root 3 into root 3, we get 3. Now 3 table, 3 ones are, 3 twos are, 3 fours are. Okay, 3 fours are 12. Next, we multiply 2 into 2.4 into 1.732. If you multiply all these things, we get approximately 8.3 meters. So this is the length of the ladder. Okay. Next, we need to find the distance, right? So length of the ladder completed, we need to find a distance. So we take a tan ratio. So tan theta is equals to opposite side by adjacent side. Tan 60 degrees is equals to opposite side is BC, adjacent side is BD. Tan 60 is root 3 is equals to BC value, we have 7.2. BD value, we don't know, it is X. Transpose this side. So we get X is equals to 7.2 by root 3. Again, rationalizing the denominator, we get 7.2 into root 3 by root 3 into root 3. So we get 7.2 into root 3 by 3. 3 table, it goes near 2.4. So when you multiply 2.4 and root 3, you get around 4.15 meters. So the distance between the foot of the ladder and the foot of the pole is 4 meters approximately. And the length of this ladder we have to use is 8 meters approximately. So this is how we have to find these unknown parameters using trigonometry. So that's all about 7th problem. Next, 8th question. So 8th question on the screen, a boat has to cross a river. It crosses the river by making an angle 60 degrees with the bank of the river due to the stream of the river and travels a distance of 600 meters to reach the another side of the river. What is the width of the river? If you see this diagram, you will be very clear. Okay. Now the stream of the river direction is shown on the screen. Point A is the starting point and point B is the destination. Due to the stream of the river, the boat cannot travel perpendicular to the current. So the stream will pushes the boat in this direction. So the boat will travel making an angle of 60 degrees with the bank of the river, and it travels 600 meters to reach the destination. And this perpendicular line is nothing but the width of the river. This is what we have to find. Okay. I hope you have understood with this diagram. Now we'll take one imaginary right angle triangle as shown in the screen. So here, if I name C is the starting point, A is the target, point B. Okay, here it is 60 degrees and this distance is 600 meters. We need to find the width of the river. Let it be D. Okay, now write down whatever the observations are there on the screen. So let AB be the width of the river. That is what we have to find. AB be the width of the river. C is the initial position of the boat. And destination is nothing but point A. That is the final position of the same boat. Now, if C and A are initial and final, therefore, AC is the distance traveled by boat. Distance traveled by the boat. Okay. And angle ACB is given as 60 degrees. So, in triangle ABC, angle B is equals to 90 degrees. Now, with respect to acute angle theta, AB will be the opposite side. AB will be the opposite side. So, AB value we don't know. So, we assume it as D and that becomes the opposite side. Next, AC we know that is 600 meters and it is the hypotenuse. So, opposite versus hypotenuse is nothing but sine theta. Sine theta is equals to opposite side by hypotenuse. Values are sine 60 is equals to opposite side is AB and hypotenuse is AC. Sine 60 value root 3 by 2. AB we assumed it as D by AC is 600 meters. Now transpositions, root 3 into 600 by 2. 2 ones are 2 3s are. So answer is D is equals to 300 root 3 meters. If you want, you can simplify by multiplying root 3 value 3732. You can do it also. Or else you can stop it here only. Either is okay. So this is simple. Next, we'll go for 9th question. As you can see on the screen directly, an observer of height 1.8 meters is 13.2 meters away from a palm tree. On the screen, you can see a palm tree which is 13.2 meters away from the little boy who is 1.8 meters tall, looking at the top of the tree. Okay, the angle of elevation of the top of the tree from his eyes is 45 degrees. Now in the screen, you can see that a black color dotted line is passing through the eyes of a observer which is parallel to the horizontal level. Now that is the imaginary horizontal drawn from the eyes of the observer, and the angle 45 degrees is marked between the line of sight and the imaginary horizontal. That is why 45 became the angle of elevation. Now here, what could be the height of the palm tree? That is h meters that we need to calculate. We need to assume that that palm tree is standing perpendicular to the ground level. So using the image given here, you please try to understand the question criteria. Now using this image, we'll draw imaginary diagram. So horizontal drawn. Next, this is a 1.8 meters tall observer. Now this is a h meters tall palm tree. From eyes, the observer is looking at the top of the tree. Through eyes, one imaginary horizontal. So this is what how to draw the reference diagrams. Now let us remove this image and go for the solution. Now here A, B is the height of the observer. Next D, C is the height of the palm tree. Now height of the observer is 1.8. He is standing perpendicular to the ground. DC is also palm tree which is standing perpendicular to the ground. And here BC is the original horizontal level. And AE is the imaginary horizontal drawn parallel to the horizontal. So therefore, ABCE became a rectangle, isn't it? That means if this is 13.2 meters, AE will also be 13.2 meters. If AB is 1.8, CE also 1.8. So up to here we have found height of the palm. If you can find DE, then add to 1.8, you will get the height of the palm tree. Okay, this is that easy. Now let us solve this one by writing the given information clearly. So let AB be the height of the observer. Height of the observer. Next, what is the height of the tree? CD. CD be the height of the tree. Height of the tree. Next, BC is the distance given in the question. Distance between observer and the tree. Okay, foot of the tree. Next, we need to assume an imaginary horizontal, that is AE is the imaginary horizontal. Very important step. Now, therefore, A, B, C, E becomes a rectangle from the figure and properties. Becomes a rectangle. Since it is a rectangle, opposite sides are equal, right? So AE is equals to BC, and that will be exactly equal to 13.2 meters given in the question itself. Next opposite side pair is AB is equals to CE, that is 1.8 meters given in the question. Now in a triangle AED we observe here, since angle C is 90 degrees, here angle E will also be 90 degrees. With what type of concept we can say that angle E is 90 degrees? Please drop in the live chat. Why angle E is also 90 degrees? Reason you drop in the live chat. Now angle AED, triangle AED, we have angle E is equals to 90 degrees. Reason you all drop in the live chat. Let me check. Now with respect to the question, we have here theta as 45 degrees. So theta is equals to 45 degrees. Now with respect to our acute angle in triangle, what we have, let us see. DE is the opposite side that we have don't know. So we take it as X. Next AE we have, it is adjacent side, right? adjacent side, and we have it as 13.2 meters. So we don't need to find the hypotenuse, so I'm not writing here. So opposite versus adjacent side ratio is tan theta is equals to opposite by adjacent. So theta value is 45 given in the question. So tan 45 is equals to opposite side x, adjacent side is 13.2. So tan theta is equals to 1, x by 13.2. 13.2, if you transpose that side, we get simply x is equals to 13.2 meters. Okay, now this one we have 13.2 meters and we have ECS 1.8. Now what is the height of the palm? Now height of the palm is equals to height what is that? DC, right? So DC is equals to, from the figure, EC plus DE. EC already we have it as 1.8 meters and DE we found 13.2. So if you add them, we get 15 meters exactly. So this is how we use trigonometry to find the heights and distances between various objects in our real life. If you can imagine the situation as it is in front of your eyes, the problems will be more easier. Next, the final question. In the adjacent figure, we have triangle ABC with the given dimensions. We need to find the area of this particular triangle. Here, this is direct application. It is not a real life application, but still, how to apply trigonometry here. You remember that ABC triangle is not a right angled triangle. Here, don't assume that angle B is 90 degrees. Here, it did not mention. We need to find area of this triangle whose two sides are given. And 5 centimeter and 6 centimeters are not hypotenuse. They are simple just sides. So using this given information, we need to find the area. So area formula is nothing but half into base into height. Since we don't have height here, we need to drop a perpendicular. Here we need to drop a perpendicular. So here it is a perpendicular we dropped. Let it be BD. Now for the triangle ABC, BD will be the height. Now as soon as I drew BD perpendicular to AC, now bigger triangle ABC is divided into two right angled triangles. One is ABD and the second one is BDC. So we don't have any information regarding the parts of the triangle BDC, so we ignore that triangle. So we consider only ABD triangle since we have AB side at least. Okay. So right, in a triangle ABC, what he gave, let us write. Angle BAC given as 30 degrees. AB is given as 5 centimeters. And AC given as 6 centimeters. This is what given. Now, extra construction that we are doing is drop a perpendicular. Drop a perpendicular to AC. From which point we have to drop? From point B. So, BD will be perpendicular to AC. Okay. Now it divided into two triangles. So let me consider triangle ADB, in which angle D I consider it as 90 degrees. And acute angle is what? Theta is equals to 30 degrees from the question here. This is 30 degrees. Now with respect to this acute angle, our BD is nothing but opposite side, and AB will become the hypotenuse. So with respect to acute angle theta, BD is equal to H will be the opposite side, and AB is equals to 5 centimeter will be the hypotenuse. So hypotenuse versus opposite side will be as usual sin theta is equals to opposite side by hypotenuse. Substituting the values, sin 30 degrees is equals to opposite side is h, hypotenuse is 5. Sin 30 is 1 by 2 and h by 5 as it is. Now transposition 5 to this side, so h is equals to 5 by 2. 5 by 2 is nothing but h is equals to 2.5 centimeters. So height we found it as 2.5 centimeters. Now you ignore all these things now. Now in triangle ABC, base we consider it as AC. It is given as 6 centimeters, and we have found height of the same triangle, that is BD is equals to 2.5 centimeters. What is the area formula? Area of triangle is equals to half into base into height, and that is half into base is 6, height is 2.5. 2 ones are 2 threes are. Now 3 into 2.5 is 7.5, and units are most important, 7.5 centimeter square. With this we completed exercise 12.1 of applications of trigonometry from class 10 mathematics. Thank you so much for joining the live session today. I hope you enjoyed it. Please subscribe to my channel for more interesting videos. Thank you so much. Thank you so much for watching. Goodbye.